Can I get a thumbs up if you hear me and see me okay? Everybody's good? Okay, so we are gonna finish what I called the day 2 and 3 notes is now the day 2, the day 3, and the day 4 notes. So hopefully we'll finish these notes today and you guys will be good to go. So guys, what I need to show you now is taking these log graphs and transforming them. Our book is huge on being able to take an original graph and transform it, right? So I've given you a list of steps to follow if you need anything to look back at. Otherwise, let's jump into the first example. This should be the last page. In case you have this page, are you okay? Okay. Okay, so they want us to graph f of x equals the opposite of the natural log of x minus 2. So right away, notice this is a logarithm with a base e. So the base is bigger than 1. So you know this should show that very slow log growth in the beginning. That's what his original graph would look like as a base e log. But now you're going to take this graph and you're going to transform it. So what I would like you to do is, number 1, let's figure out who was the original function, right? The original function would have just been f of x equals the natural log of just x, right? Pre-transformation. So you're dealing with a base e log, a number bigger than 1, and his graph would have looked like this. Let's establish some of that original information about his graph. This graph would have started with a domain where we're taking the log of x, so x would have to be greater than 0. So we're starting with that domain, which is, if you're going to start with a domain x is greater than 0, it's automatically going to put your VA at x equals 0. You're not going to go past that x value. All right, let's create some original ordered pairs on the graph of the natural log of x. So guys, if we create, let's say, 3 original ordered pairs, right? When I'm working with the graph of a log, I like to control the exponent. So I'm going to pick -1, 0, and 1 as 3 really easy, close to the origin exponents. So if -1, so if the natural log of x equaled -1, e to the -1 is 1 over e. That's who we would have plugged in to get -1 out. All right, if my exponent was 0, if this equaled 0, e to the 0 would be that, which is 1, because e to the 0 is 1. And then if I picked 1 to be an exponent, if this equaled 1, e to the power of 1 is e. That's what we would have taken the log of to create that exponent of 1. So these are 3 original points on the graph of that original graph. So 1 over e, guys, just to give you guys perspective, it's like 0.736. And e is about 2.718, just to give you guys numbers to picture on the graph. All right, so that's what the original graph would have looked like. That's all of the original information, right? Now, let's figure out what changes were made to this equation that would have affected these points. Well, this negative sign is on the outside of the function. So that's going to times the y values by -1. So that would have caused the y's to get timesed by -1, which is going to cause all of your y's to change sign. So it's going to cause an x-axis reflection. So picture this. Now, if this graph is reflected over the x-axis, now it's looking like that. Now it's kind of looking like log decay. All right, this inside the function is clearly being done to the x's. But whatever is done to the x's has the opposite effect. So x minus 2 actually takes the x's and adds 2. So that's going to shift the whole graph to the right 2 units. So now picture this graph right here. Now he'd be shifted to the right 2 units. So now his graph should look like that. So this is what his graph should end up looking like. So now let's make these changes to the original information to create his graph. All right, well guys, let's look. If you started with a domain of x being greater than 0, look at this function. Who's his domain? X minus 2 would have to be greater than 0, which means x has to be greater than 2, because you've taken the x's and you've shifted them all to the right 2. So now x can't be 0. When I shift to the right 2, now x has to be greater than 2. So that's going to put a VA right at x equals 2. I'm not going to go past an x value of 2. So that's going to cause his VA to be at x equals 2 now. All right, let's see this ordered pair. What's going to happen to this ordered pair? We'll take your x value and add 2 to it, right? So take your 1 over e and add 2. That's his new home. Take your -1 and times it by -1, which is now +1. And remember, 1 over e is about 0.736, so this is about 2.736. So put that on the graph. 2.736, 1. All right, take this point. The x has to get shifted to the right 2, so 1 plus 2 is 3. His y-coordinate has to be times by -1, which will still be 0. So now 3, 0. And then this point, take e, shift it to the right 2. So now it's e plus 2, which is again, 2.718 plus 2 is about 4.718. Take 1, times it by -1, and now that new y-coordinate is -1. So 4.718 and -1. So now look, what's this graph going to do? It's going to connect these 3 dots. This one's going to head off towards that asymptote, and this one's going to show that log decay. And there's the graph of your transformed function. Is that okay? Everybody good? Okay. So now we've created the graph. Now they're asking us for some information. Guys, I apologize. This is probably going to get a little crammed. So let me know if you're struggling to see what I'm writing. They asked you to state the domain of f of x. So guys, here's f of x. What did we say his domain was going to be? His domain is x has to be greater than 2. I think they're going to make you write it in interval notation. So his domain is from 2 to infinity. Look at his graph. Only x values to the right of 2 live on this function. From the graph, determine the range and the vertical asymptote of f. Well, guys, the range. What y values live on this graph? Who comes out of this logarithm? Who does this natural log spit out? An exponent. And what's the exponent allowed to be? All real numbers. The exponent's allowed to be anything. So the range is all real numbers. The vertical asymptote, we already said, if my domain is x is greater than 2, then that's going to put a VA right at 2. Your vertical asymptote is x equals 2. Everybody okay? Yes? All right. Now we go to the next one. The next one says they want you to find the inverse of f. They want you to find the inverse, the function that will undo this function right here. Well, guys, let's get some perspective. This is a logarithm. So his inverse has to be what kind of function? What function undoes a logarithm? An exponential. The inverse has to be an exponential. And if this is a base e logarithm, we need a base e exponential to undo it. All right, let's do it. So we're going to find the inverse. Take the function, f of x equals natural log, the opposite of the natural log of x minus 2. I'm just going to put y instead of f of x. Y equals negative times the natural log of x minus 2. Well, guys, remember what's happening on an inverse. The x's and y's are literally trading roles. So to create an inverse, you have to take the original function and switch his x and y. We have to make them switch roles. So switch x and y. Oops. Okay, believe it or not, this is the inverse to that function. This will undo what that function is doing. However, this is what we call that implicit version of the inverse. It's not the one we want, right? We want the explicit form of the inverse. We want y to be by itself. So now you have to solve this for y. So we have to start getting y by itself. So let's start by dividing this negative sign on the outside that we can get to away. So now we have this. The opposite of x equals the natural log of y minus 2. Now we're kind of stuck because the y that we're trying to solve for is stuck inside this logarithm. I can't just go in here and start adding 2 because this lives inside of that logarithm. So it's going to get a little crazy what we have to do. So let me do it this way. I just want to rewrite this in the opposite order. I want to rewrite this as the natural log of y minus 2 equals negative x. My brain just functions better when it's written like that. I just put them on the other side of the equal sign. So guys, right now, we are in a logarithm. We are in log form. We need to get to exponential form. So the base of this log is assumed to be e. So now you have to take this log form, you need to rewrite it in exponential form. What would exponential say about a natural logarithm, base e of y minus 2 equaling negative x? So use your log loop to put this in exponential form. This log is saying that e to that exponent equals that answer. So let's put it in that form. So e to that power equals that answer. So now the logarithm is gone and we are working with a base e exponential. And now all we have to do is add the 2 over to get y completely by itself. So now where can I go where you guys can see this? Now we're going to have y equals e to the negative x and then plus 2. Can you see that? Yeah. So that is the inverse of that function up there. So I'm going to put it in its fancy inverse notation now. I'm going to say f inverse of x equals e to the negative x and then plus 2. Does that make sense, Case? You okay? Okay. So we switched x and y. We started to get y by itself. You basically have to isolate the log. And then once you isolate the log, you can convert to exponential form. And then there's where the log will go away. And again, it makes sense that a base e exponential is what's going to undo a base e logarithm. All right, now they want you to find the domain and range of the inverse. Well, guys, don't kill yourself, right? His domain is the inverse's range. We said the range of the original function was all real numbers. So that means the domain of the inverse is all real numbers. And it makes sense because the domain are your x's, and the x's are back to being exponents, and the exponents allowed to be anything. The range of this inverse is the domain of the original function. We said the domain was 2 to infinity. Think about it. This natural log, he just got shifted up 2 units. So he's going to have a range from 2 to infinity. Okay, now they want you to graph the inverse on the same set of axes as the original. So guys, don't worry about going through all the troubles of graphing this. We're literally just going to take his ordered pairs and reverse them to create the graph of the inverse. So think about this. If the original function had a VA at x equals 2, the inverse will have an HA at y equals 2. If his x's can't be 2, then his y's won't be 2. So he's going to have an HA. I wonder if I can do a different color. Nope, that don't work. Maybe not. Oh, okay. So now that's the horizontal asymptote of this exponential, because exponentials have HAs, not VAs. All right, and then let's start switching up ordered pairs. If this is the point 2.7361, then 1, 2.736 is on the graph of the inverse. So 1, what did I say? 2.736. Boom. All right. If 3 zeros on the original, then 0 threes on the inverse. If e plus 2, negative 1 is on the original, then negative 1, e plus 2 is on the other one. So negative 1, 4.718. And now look what it's going to do. These 3 points are going to connect. They're going to hug that HA, and then they're going to shoot off to infinity. And it looks like if you took the black curve and reflected it over that line y equals x, that's exactly the curve we should end up with. How'd that feel, okay? Thumbs up at home, everybody okay with that? So they ask you just a laundry list of steps. So this is like going to be one of those homework assignments where each problem is like complete parts A through F. I'm sorry, I apologize about those. All right, let's try this again. Let's try it with a new problem. All right, I answered all the questions? Yes. the logarithmic function f of x equals that. So you guys do that at home. Find me the domain of this logarithm. I'll do it here, you guys do it there, and we'll see if we get the same answer. All right, look at this function. I am taking the log of x plus 1. So x plus 1 has to stay a number bigger than 0 because I'm only allowed to take the log of a number bigger than 0, which means your x values have to be staying bigger than -1, right? So now my domain is from -1 to infinity, which, guys, automatically tells you if all of my x's are going to be bigger than -1, then we already know he's going to be our VA. I'm not going to go past an x value of -1. So even though they didn't ask for the VA yet, I still want to put that in my head that as long as I know who the domain is, I know where that VA is going to be created. All right, then it says graph f. We have to graph the function. All right, so B, in order to graph it, let's recognize who would the original function have been with all of these changes. It just would have been the log of x, which that's the common log, guys. This is the base that's assumed to be 10. This is a base 10 log. So that means if the base is 10, bigger than 1, the original graph would have shown that logarithmic slow growth. So his graph would have looked like that. All right, his domain would have been x is greater than 0, which would have put a VA at x equals 0. Just like all original log graphs start with, they start with that VA at x equals 0. All right, let's get some ordered pairs that were on the original graph. I like to work with my exponents, so I picked 3 really easy exponents that are close to the origin. All right, so let's come up here. If my exponent was -1, if this equaled -1, then 10 to the -1 is who we would have taken the log of, which is 1 over 10, 1/10. If my exponent was 0, if this equaled 0, 10 to the power of 0 would have been 1. 1 is who I would have taken the log of. And there's that original x-intercept that all log graphs start with. All right, and then what if I wanted my exponent to be 1? 10 to the power of 1 would have equaled 10. 10 is who I would have taken the logarithm of to get 1 as my exponent. Does that make sense, Casey? Yes. Okay. All right. Now let's go to the transformations. What is happening to these ordered pairs to create the new graph? Well, guys, look here. I got this 3 on the outside. So he's on the outside of the function. He's going to multiply our y's by 3. So that's going to vertically stretch out this graph by a factor of 3. All your y coordinates are going to be 3 times as big as the original. And it's not negative, so there's no reflection. It's literally just going to make this like 3 times a vertical stretch. And then inside the function, I'm taking x and I'm adding 1. But I know that has the opposite effect. So I'm going to take all my x's and minus 1, and it's going to cause the entire graph to shift to the left 1 unit. All right, let's make our changes. So guys, look at here. We already said this one has a domain of x being greater than -1. We know he has a VA at x equals -1, right? If I take this VA that used to be at 0 and shift it to the left 1, now it's sitting at -1. So I know I have a VA at x equals -1. Now let's switch our ordered pairs. All right, if 1/10 was on the original one, I have to take that and shift it to the left 1 whole unit. So what's 1/10 minus 1? -9/10. Take -1, the y coordinate, and make it 3 times as big, -3. So now, -9/10, -3 lives on this graph. All right, go to the next one. Take 1, the x coordinate, subtract 1 from it, so now it's sitting at 0. It got shifted left 1. Take 0, times it by 3, but it's still 0. But the original x-intercept got shifted to the left 1. And then 10, take away 1, now it's sitting at 9. And then take 1, times it by 3, now the point 93 lives on this graph. think it stops at 7. And there's your graph that has been shifted to the left 1 and vertically stretched by 3. Everybody good? All right, okay. So we've graphed it. Now from the graph, determine the range and the vertical asymptote. So the range, look at it. Who's coming out? Who's y on this graph? Well, guys, it's an exponent that's coming out of this logarithm. An exponent can be anything. It's all real numbers. The VA, we already said, is sitting at x equals -1, right? Where that domain started. All right, now they want you to find the inverse. This is probably the one takes us some work from us. So if we're going to find the inverse, can I go here? So take the function. I'm just going to write y. Y equals 3 times the log of x plus 1. All right, to create the inverse, everybody switch x and y. And again, perspective. If this is a base 10 log, then we're going to need a base 10 exponential to undo that. All right, well, again, the way my brain works, let's isolate that log, so divide by 3. I like to rewrite this. I want to put the log of y plus 1 on this side equals x over 3. It just, for my log loop's sake, makes more sense to me. Okay, so now if I want to get to y, he is stuck inside that logarithm. So we got to get rid of this log in order to get to that y. So we're going to have to change this from log form to exponential form. This is a base 10 log. So what does your log loop say? Your log loop says 10 to that power equals that answer. So 10 to the power of x over 3 equals y plus 1. Just going up there now. Sorry, I have very limited board space. All right, and now get y by itself, -1. And there's your inverse function. All right, so we're going to write him a little bit fancier. F inverse of x is equal to 10 to the power of x divided by 3 minus 1. Everybody good? Okay, now they want the domain and range of the inverse. I have nowhere to write this. I am all over the place. Okay, so his domain and his range. His domain is the range of the original function. And what did we say the range of the original function was? All real numbers. Because guys, look where your domain is back to being. Your domain is back to being an exponent, and the exponent can be anything. The range is the domain of the original. The domain of the original was -1 to infinity. All right, because this is a log graph that has been, again, that vertical stretch by 3 is going to control where your HA is and your VA was. All right, now they want you to graph the inverse. So we're going to switch all of this information. So if the original had a VA at -1, this one's going to have an HA at -1. And now let's switch our points. Now, -3, -9/10. 0, 0. So 0, 0 actually lives on both their graphs because he's literally on the line of reflection. He lives on the line y equals x. And then 3, 9. And now I'm going towards that asymptote, 0, 0. And then there's your exponential growth for a base 10 exponential. Right? So we got our exponential growth being shown now. How's that feel? Okay, Case? Okay. Everybody at home, how do you feel about that? Everybody good?
I think it's 9, 3, not 3, 9.
Oh, I plotted 3, 9? Well, 9, 3 was on the original, so 3, 9's on the inverse.
Oh, okay.
Right, so 3, 9 would be on the inverse's graph. Okay? All right, so that's what your homework tonight is going to deal with. It's going to give you questions where you're going to get a function, answer it, graph it, create all of it, and then you have to create that inverse and get all his information and graph it. All right, let me double check the attendance. Guys, I haven't made the homework is due Sunday night. So tomorrow I have one more thing I still have to teach you, log equations. And I don't know if we'll get through it at all of it. So this may go into Monday, but next week, I'm planning on giving you guys basically probably either starting Monday or after Monday, you'll have the whole week to work on a study plan for 5-3 and 5-4. I'll keep the points low, don't worry. And then your quiz will probably be Friday on these two sections because I'm not going to be here. So I'm Wednesday, Thursday, Friday. So I'll leave you a study plan and then a quiz. All right. I think I have everybody attendance-wise.